Okay, students, so here's a digital scale, and this is going to be different from what you used in middle school, which was the triple beam balance. Now, the first thing, no joke, I find a lot of people mess up on is that there's a lid. See that clear thing? You have to lift it up. A lot of times students do this and they're like, why is it not working? The answer is you have to lift the lid up. That's a protective layer. Next thing is that there's an on button, so you're going to turn that on. Wait for it to light up, and sometimes it goes through just different little things in here. There we go. So now it's saying 0.00 grams. Okay, so when I am going to weigh something, I don't want to put it directly onto the scale. Now, as you can see, there's little things like, I left that on purpose so you could see that. There's just little damage that is caused when you put the chemicals directly onto the scale, so we don't want to do that. So what we do is we use something called weigh paper. Now, I'm at home, so I'm just using a paper towel. It doesn't really matter, honestly. It's just a protective layer so you don't damage the scale. So I'm going to put the paper towel and see how sensitive the scale is. It already weighs the weight of that paper towel, or not weight, weight is different from mass. It's the mass of your paper towel. And so we don't want that, because I am going to show you how to record the mass of solids versus liquids on this scale. So I need to get rid of that solid paper towel mass. I don't want it. So what do? We have a feature in science where we have something called a zero button, or sometimes it's written as a tare button, T-A-R-E. You're gonna push that. It's gonna just zero out the weight of that paper towel. And now I'm just doing something basic like sand. So I am going to take the sand and just put it, scoop it out and put it straight on the scale. So let's say this is a chemical. There we go. And it's very basic. See how easy digital scales are? That's why we use them. I do want to point out that sometimes these scales read more digits. The more digits that it reads past the decimal point, the more expensive the scale is, because that's how accurate it is at weighing or actually, measuring the mass. And so I don't want to say weighing, but measuring the mass. So the other thing I wanted you to notice is that sometimes these things fluctuate, okay? It goes up and down a little bit, and that's just, sometimes it can be air movements. What I always say to my students is record the number that it stays on the longest. And the other thing is just maybe your scale needs to be calibrated, or it's old. This is just old and cheap, so it just keeps changing a little bit. So that's actually an important point. So I'm gonna put 1.47. So the weight, the mass of the sand is 1.47 grams. Okay, now this is a good time to bring this up. We just saw that this last digit kept changing. The last digit is known by science to be not valid. It changes. We saw it changed. So this is what we call the uncertain digit. So the last digit is always the uncertain digit, okay? And so you have to record the last digit, even if it keeps going up and down. And that's actually a good point that most students are saying, hey, well, what do I write down? The last digit's going up and down. Am I supposed to write that? Yes, because all scientists know that the last digit is uncertain, okay? And this comes up when you talk about, in higher level chemistry, what we call significant figures, because that last digit is unknown. It's significant, and we say it's significant because the scale was capable of measuring all of those digits, but the last one is just uncertain, okay? So I would say that that's 147 grams. And so that's how you weigh your solids on the scale.